Hi everybody, I just wanted to pop in and make a video explaining how we read topographic maps. This is something that's important for you in this class. It's going to probably be on some quiz questions or exam questions, and I wanted to make sure that that's something that we can do before we move on to anything else. So I have here on the screen a topographic map. It doesn't matter where this particular map is, but this one's from Montana. And so this one is not really much here on the map. There's not really a whole lot of towns, cities, I don't really see a whole lot going on here, but there's a lot of squiggly lines, and those squiggly lines are meaningful to me. Each of these lines that's squiggly represents a line of equal value. It's something that we call an ISO line. We use ISO as a prefix, meaning the same, like isolate. We're isolating a value for each of these lines. Geologically, these are topographic lines, so we call them contours on a map like this. So these are topographic contours. We will later in the semester see some maps that are like weather related, and they have lines of equal air pressure on them, and those will be isobars. We can have lines of equal wind speed as an isotac. We can have lines of equal any insert value here on a map, but for this purpose, this is a topographic map. These are contours, lines of equal elevation. So there's a lot happening with these squiggles here, and it looks really confusing at first glance, and that's okay. It is confusing at first glance. What I want to look at here, I can't really zoom in much further on this, but you can see if you follow my cursor, there are some bold squiggles and some less bold squiggles. So I'm looking over here because it's nice and spread out and easier to see, but there are some other places on this map that you can see it also. So the bold ones, those are called index contours, and those you can follow around and usually find a value for what is represented here. So up here in the upper left corner, you can see this one is 6,000, nope, this is 5, 7, and 9,000 meters of elevation. So this is showing me that this is a peak. This is coming uphill to the peak of a mountain, is what this is representing. And you can work backwards and figure out the contour interval for each of these squiggly lines. You just have to figure out how many numbers are represented between each one. So those are index contours and contour intervals. They show us what's happening with the elevation. If I wanted to read this map, you can see up in the upper right here, these are really spaced out. That shows a more gradual change, whether it be topographically, like in this case, or if it's a gradual change on a weather map or temperature map or anything else like that. So here I see a gradual change in elevation. This is a much shallower slope, probably someplace that would be more friendly for climbing, building roads, things like that. Versus in the middle bottom of the screen here, there's a lot happening. You can hardly even see these contours in some of these places. That's very, very steep. That's a very quick change over a short distance. So this is a very high gradient, as I would say, very steep slope. So not a place that I would want to build a road if I was looking to build a road based on this location. And you can see there's a railroad here. It follows the more shallow contours. This looks like a road here. It doesn't go anywhere near these really steep parts. They probably had to excavate some of these mountain pieces, and we can see there's a pass, Bozeman Pass. So they probably had to excavate some of the mountain and make road cuts for this road and this railroad. But what I really want you to be able to do and get out of this is that there are shallow parts, there are steep parts, there are index contours, and there are contour intervals. Can you read that? There are other things. If I exit out of this, let's find a new place on our map. We can zoom in here if my computer loads. There we go. We can come right over here to Battle Creek. I can find a map of Battle Creek. There are some squiggly lines on here. Contours. There are bold lines. Index contours. There are things on every map that exist. Whether you are looking at a topographic map or a road map or your GPS, things that always exist are going to be a title of the map. Where are you looking at? What are you looking at? And you can even pause the video and see if you can come up with the other 4 pieces that go on every single map. So we've got a title. Where is the map? You should always have a date on the map. When was this map made? Because this map in front of you on the screen does not look the same as this map. They look different. Because this map in front of you right now is from 1918. And the map that I just had up was edited in 1932. So things changed between 1918 and 1932 in Battle Creek. We probably expanded. Land got changed for its purpose. It maybe changed from like farmland over to urban land. Roads were built. Things like that. Rivers changed their course. Lakes can be man-made, or they can be drained, depending on what the climate is like. So the date has to be on every map. Location, date. What else has to be on every map? A scale bar, or a scale of some sort. There are 3 different kinds of scale that you'll read about in your book. This one, the scale bar, is along the side here. This is a bar scale. There's also one down here. And if we zoom in, it tells you what the contour interval is. It tells you the representative fraction scale, and it has a bar scale. The third thing that they all have, 4th thing, I've lost count, is a compass arrow. It's down here. This particular one doesn't look like much of a compass, as far as you may be aware. That's okay. This is a north arrow. It's indicating which way is north. Because if I take all the words off of this map and you don't have any words to go off of, how do you know which way is north? You don't. You need a north arrow. These USGS topographic maps always have a true north and a magnetic north. So it's going to tell you what degrees off you need to set your compass for your declination, as it's called. So that is a little beyond the scope of this class, but that is pointing north. So you know which way is north on this map. So we've got a scale bar, we have a date, we have a title, we have a compass. What else do they all need to have? Some sort of key or legend to tell you if there are icons on here, what the icons mean. Let's see if we can find it on here. Sometimes they're a little bit trickier in the older topographic maps. There are standard symbols that go on topographic maps. The USGS, United States Geologic Survey, has standard symbols that belong on a map. So all wells that are drilled have the same symbol. All mines, depending on the type of mine, have the same symbol. Roads, railroads, things like that, they all have the same symbol on topographic maps like this. So this one doesn't necessarily have a key on it, but it has a key that goes with it. And a lot of these things that are on here are labeled. So here's the Michigan Central Railroad that's coming up through here. And you can see each of these little dots represents something. This one's a school, this is a school, things like that. So there are 5 things that belong on all maps. I hope that you, if I give you a map, you would be able to pick out those 5, or even tell me a little bit more about those pieces. All of these are on all maps. They may not be seen, but they're there. Even down here on your GPS, something like this. This is a scale bar that tells you how what that means. It tells you the location that you're at visually down here because this is a movable map. It has a scale down here at the bottom. It tells me date-wise. I know because I can click on these and get the dates over here on the map. But this underlying map is a Google map, so it's generally up to date. I can trust that map is a modern map. The state of Michigan is not going to change its shape in a short period of time, so it's going to be pretty consistent. And then, of course, I have a key buried in each of these individual maps. So if you have any questions on this content, please send me an email. I am happy to answer them. Otherwise, you should be able to read more about this in your book in the reading for the week. We'll see you next time.